Okay, so we look down below, there's going to be 3 different templates, okay, meaning 3 different type of electrolysis in this whole chapter. The first one is separation of ions of a molten ionic compound by carbon electrode. Okay, meaning when they use carbon electrode, straight away we know that it's an inert electrode. If it's an inert electrode, it will not take part in the reaction. So whatever cation, anion you have inside your aqueous or molten form, they are the ones that will become back the element, not the electrode. Okay, so example, if you have, let's say the first one, if your electrolyte is a molten form of lead-2 bromide, molten means it's just dissolved straight away. So the ions present, you have your Pb2 plus and your Br minus. These two are the ions that are floating around the solution. Okay. If your electrode is platinum, means it's an inert electrode, it will not take part in the reaction, so I can just don't care about it. So it's mainly these two that is happening. The cation will go towards the cathode to gain back electron to form back your lead. Okay, so that's why at the cathode, this is what's happening. This is the half equation. Okay, at the anode side, your Br minus is going towards the anode to minus your electron to get back your Br. Okay, but because Br is a diatomic molecule, it's group 7, it must be in 2s. So that's why we balance the 2 and the 2 here. Okay, but then, so initially it's minus 2 electrons. So same thing, we don't like to see the minus. That's why it's bring over to become a 2 electron here. Okay, maybe I write it down here. See. Okay, so like your, okay, so the cation, the cathode part, okay, the Pb2 plus will gain back 2 electrons, okay, because the charge is 2 means you need to take back another 2 to form back your Pb, which is your lead, the metal. So you'll see a metal forming over there, okay, but at the anode side, the Br minus is actually losing electrons because it goes through oxidation, right? It's going towards the anode to give you back your Br atom, okay, but then Br alone must be in 2s. So you put a 2 here, then you need to have 2 of these bromine ions minus 2 electrons to give you back the Br2. Okay, but then they don't like to see this negative here. Okay, so what they do is you still retain this one, then you give the arrow, this one just bring over to the other side. So it's Br2 plus back 2 electrons. Okay, so that's why your anode side, your half equation is like that. The cathode side, the half equation is like that. Okay, this part can follow. Okay, yes. Okay, so then after that, if they ask you to get the full equation, okay, so full equation, how do we do it? You add up both half equation together. So example, all your left side, you add up together, it will give you everything on the right side. Okay, so in this case, you have your Pb2 plus 2 electron plus 2 Br minus. You put it here, left side. Okay, then the right side got Pb and Br2 and 2 electron. Put it here. Okay, then you notice left and right both got 2 electron, so you can cancel away. Then your Pb2 plus and your Br minus is an ionic compound, so you can crisscross them back into PbBr2. Okay, the ionic compound. Then these two remain the same. So in other words, the overall equation is telling us that this molten electrolyte is eventually broken down into your lead at one side, you get lead, the other side you get your bromine. Okay, so that's how you get this overall equation. Okay, overall equation, you must be careful. If your left side is, let's say, 1 electron, the right side is 2 electrons, then you cannot cancel away. So what should you do in this type of cases? If your here is 1, you just make sure you times everything to become the 2 electron. so that you can cancel away the equal number of electrons. Okay, so that is if you have to do overall equation. Make sure your number of electrons on left and the right must tally up. So you just times multiply accordingly, then you minus, you tally up already, then what is left over, you should get the balanced electron and the balanced compound. Okay? Okay, another one, so if let's say your ions is in an aqueous solution, so just now was molten. Molten means straight away one cation, one anion. But if it's an aqueous, because you're adding in water, water itself is able to dissociate to give you H plus and OH minus also. So that means, if for example, you have a sodium chloride solution, aqueous form, means I don't only have one cation now. I have my Na plus, I have my H plus, I have my Cl minus, I also have my OH minus. But if I'm going to discharge, I can only discharge one. So between the two cation, I must choose one. Between the two anion, I must choose one. So that is called selective discharge. So got some rules to follow, which one to discharge. If it's the cation side, this table is very useful. We always discharge the one that is less reactive. So this table is actually your reactivity series table, potassium all the way to silver. So example, if you got potassium and you also got H plus, they will choose to discharge your H plus. So H plus will gain back electron to get H2, they balance the two here. So this will always be the half equation if you got any of this involved with your H plus. Okay, but if you have your H plus with copper or silver ion, then you have to choose the copper or the silver, the one that is less reactive. So if you choose the copper, then you can gain back 2 electrons, you'll find that copper will form on the electrode. If it's silver, you gain back 1 electron, then you find that the silver is formed at the electrode. Okay, so this is for cations. If it's the anion, then usually, if you got all the anions, we always choose the OH minus if you have OH minus inside. So OH minus, you just memorize this half equation. For OH minus, you will get 2 water plus oxygen plus 4 electron. Just memorize this one. Okay, so you will always discharge the OH minus. But if the concentration is very high, so example, they say they got like concentrated sodium chloride. So if it's concentrated, then I cannot choose OH minus. If I have Cl minus, Br minus, I minus, I would rather choose the Cl minus, Br minus, and the I minus to be discharged. Okay, but if I still got my SO42 minus nitrate, I still choose my OH minus. This one no change. Okay, but this one is provided if it's concentrated, they use the word. So between the Cl minus and OH minus, then I will choose my Cl minus, the group 7 ones. Okay, if not, just still choose back OH minus. Okay, then you got your both half equation. Then your overall equation, the same thing, left and the right add up together. Okay, so example, right? Let's say you have the electrolyte is dilute. Okay, they use the word dilute, aqueous sodium chloride. So straight away inside, you must know that there's your Na plus, there's your Cl minus. Because it's aqueous, there's also H plus and OH minus. So between Na plus and H plus, at the cathode side, it will attract H plus. Okay, both will be attracted, but it will discharge H plus. Then for the Cl minus and OH minus, on the anode side, it will discharge the OH minus. Okay, so your OH minus, so this is your half equation, the one that you memorize. This is also your half equation for H plus, gain back 2 electrons to get your diatomic hydrogen. Okay, Xavier, you hold on a while. Okay, so if it's the overall equation, same thing. Left and the right add up together. 4 electron, you cancel away. Okay, how come there's 4 electron here? So same thing, because here's 2 electrons, right? So the whole thing I times 2 first. So I got 4, 4, 2. So then I put in 4, 4, and the 2 here. Okay, then you cancel, then you end up, this is what you get. So the water is actually the one that is breaking down to give you back your hydrogen and your oxygen. Okay? Okay, so far okay? Okay, hold on.